All right. So today we're talking about equilibrium. And yesterday we talked about, I told you the story about Grad Bash and about moving people, right, across through from Islands of Adventure to Universal and back and forth, and how when a system is at equilibrium, these arrows indicate that the system is reversible. So, one thing, the arrows going in both directions indicate that the system is reversible, which means that the reaction can go in both directions. I actually could write this reaction in both directions. The second thing is that this system will reach an equilibrium. It will reach an equilibrium where the change between the forward and the reverse reaction are equal. So what's happening between the forward reaction and the reverse reaction is equal. Therefore, the concentrations of the products and the reactants do not change. Okay. Now, this reaction we're going to be working with today, right now, is exothermic. So you need to know that. How do we know that? Because it's negative heat. The delta H of the reaction is negative. That little circle means that it's a standard delta H and can be found on the chart. So this delta H is negative. So that means that, as we've seen, you could rewrite this as carbon monoxide gas plus 3H2 gas, and then our little equilibrium reversible arrows, CH4 gas plus H2O gas. And then we can add our heat in here, 206.5 kilojoules. And we can do that because our heat is negative. So we know that it's going to be exothermic. Now our heat becomes like a product. Okay, now when we're looking at this, there's a couple things that you want to know. First, the fact that these are all gases, there are a few things that we talked about. One, we talked about when we add, we shift away, which means we're going to, if we add a reactant, we shift to the products. That means we shift to making more products. If we take away, we shift toward. So in other words, if we take away a product, we shift toward and we actually make more products. So if we take methane away, we're going to shift this way. We're going to increase the methane and we're going to increase the water because we're going to shift toward the products. And we define that as shifting left toward the reactants or shifting right toward the products. The next thing is if we increase the temp, it is exactly like increasing one of the reactants or the product. So in this case, it would be like increasing a product. So increasing the temp is just like changing a reactant or a product. Okay? So let's take a look. Now I've set up a little grid here. And you can set this grid up too. I'm going to move this up just like this. You can set this grid up too. All right. And so first we're going to define the shift when we do this. And then the next thing we're going to do is we're going to determine the change in each one of the concentrations. So here we go. In this reaction, first I'm going to add carbon monoxide. So I look, carbon monoxide is a reactant. So I'm going to add a reactant. So I'm going to shift away, which means I'm going to shift to the right, shift right, which means my carbon monoxide concentration will go down. My hydrogen concentration will go down. My methane concentration will go up. And my water concentration will go up, right? Because I'm shifting toward the product to the right. Adding hydrogen, the same thing will happen. I'm going to shift to the right, shift right toward the products. Carbon monoxide will go down. Hydrogen will go down. I'm going to increase my methane because I'm going to shift to the right, and I'm going to increase my water. When I add methane here, okay, when I add the methane, I'm going to shift, add, away. So I'm going to shift left. I'm going to increase my carbon monoxide, shift left. I'm going to increase my hydrogen. I'm going to decrease my methane because I'm shifting left. And I'm going to decrease my water. If I add water, I'm going to shift left. So I'm going to increase my carbon monoxide, increase my hydrogen, decrease my methane, and decrease my water. Now, it's important to put in here, before we keep going, that only, and this is very important, only gases and aqueous work with this concept of adding and decreasing concentrations. Solids and liquids do not work because you cannot change You can't change the concentration of a solid. A solid has a density, and you can't change that. And a liquid has a density, and you can't change that. So since you can't change the concentration of those by adding more particles per volume, you can't add to this. You can't change the concentration. So therefore, this adding and taking away shift only works for gases and aqueous. I'll show you that in the next problem. Let's keep going. Okay, so remove carbon monoxide, so take away toward. So we're going to shift left. I'm going to increase carbon monoxide, shifting left toward reactants, increase, decrease, decrease. Removing H2, shift left, moving H2, shift left, increase, increase, decrease, decrease. Take away methane here, shift right toward the products. So decrease, decrease, increase, increase. Removing the water here in a product, I'm going to shift right, take away, toward. Take this away, shift toward. Shift right, decrease, decrease, increase, increase. Now, what about if I increase the temperature? Well, that would be adding a product. So if I increase the temperature, I'm adding a product, so I'm going to shift away. So I'm going to shift left, which means I'm going to increase my carbon monoxide. I'm going to increase my water. I'm going to decrease my methane and decrease my water. If I decrease my temperature, drop that to 06.5, then I'm going to shift right. So again, shift right toward the products. Then my carbon monoxide will decrease, my methane will increase, and increase. Now, if I increase the pressure, this is an unusual one. It only works with gases, only with gases. If I increase the pressure, we move toward lower moles. Move to lower moles. You move to lower moles. Only with gases. Move to lower moles. So let's take a look at this, okay? Here I have 1 mole here and 3 moles here. And here I have 1 mole here and 1 mole here. So in this case, I have 4 moles going to 2 moles. So it would be increasing the pressure, we're going to shift right. And that shift right is going from 4 to 2 moles. Because since we're increasing the pressure, there's less room. So you're going from 4 moles to 2 moles. Okay? Less room. So 4 moles to 2 moles. But it only works with gases. I can't express that enough. Gases only. Okay? So since we're shifting right, that means we're shifting toward the products. So decrease, decrease, increase, increase. Now if we decrease the pressure, then the volume increases. So if we increase the pressure, the volume decreases. But if we decrease the pressure, the volume increases. See that? So that means there's more room. So in that case, we're going to shift left, because when we shift left, we're going to go from 2 moles to 4 moles, because now we have more room. So when that happens, we increase left. On the left, we're going to increase our carbon monoxide, increase our hydrogen, and decrease our methane and our water. Okay, now, what if we didn't have all gases? What if instead we were putting solid, barium chloride into water and having it dissolve into its ions? And that was exothermic. Well, if that was the case, one of the important things here is that solids and liquids, and we talked about this above, don't affect equilibrium. They don't affect equilibrium, solids and liquids. Only gases and aqueous do. So now I've set up a little chart. If we add solid barium chloride, to the system, there will be no shift. There will be no shift. So we're just going to write none here. And the reason there's no shift is because the solid does not affect the system at all. So since there's no shift, then there's no change, and no change. Then if we add the Ba plus 2, there is going to be a shift. And that shift is going to be to the left. So there's going to be an increase in the solid and a decrease in the ions. Because yes, we can increase this concentration, which will shift us to the left. Now when we add heat, that also will shift us to the left. left toward the reactants. So we will have an increase in the barium chloride solid, and we'll also have a decrease in the barium +2 and the chlorine minus. Okay, so I'm hoping that you kind of got an idea about this. You have a double-sided worksheet where you have three opportunities to do exactly this chart that I just did, okay? Exactly this chart. Arrows are fine, taking care of exactly this, okay? Make sure that you remember that only gases will have any change due to increase or decrease in pressure. And that's going to go from, if you increase the pressure, a decrease in the total number of moles. Look at your coefficients. And only gases and aqueous have any effect on this. So if you change the solids or liquids, no effect will take place. All right?